welcome to our SPICE program. My name is Claire, and today we're covering functions. So, what are functions, and why do we need them? So, it's generally considered bad coding practice to just have a file with long lines of code. You want to make your code as legible as possible. And so programmers tend to divvy up their programs into functions. I like to think of functions as paragraphs to your whole essay. It helps the legibility of your code, but also keeps you from writing code that is repetitive. And so, what are functions? Functions are defined sections of code. They can also be called methods or modules. They're very similar to mathematical functions, where you have a input and then that input is given a certain operation and then it returns as an output, just like y equals mx plus b. For example, we have the mathematical expression just x plus 2, and we can write it as a function kind of like this. And so here we'll go over like the syntax of a function. You have every function to be defined. You have the DEF, and then you have your function name, which can be technically named anything, but of course we want to name it something related to what we are doing in the function. And so we have a given input x, and then we're just adding 2 to x, and then we're returning that value. So that's how you would create your own function, and we'll discuss that more in a bit. But also to note is that Python has its own built-in function. Briefly, every data type that we covered is known as a class. A class can be thought as a descriptor for an object, and each object has its own functions. So Python has like these predefined classes, and technically you can define your own class, but that's outside the scope of this lesson. And so each object is of a class, and each object has its own functions. And so, for example, we're going back to strings. So strings are its own class, and it has its own functions. So we can use these built-in functions by having an instance of this object. So here's our string object hello, and so we can call a function by just using dot whatever the name is and then parentheses. So in this case we're using the function upper, which makes every character in your string to uppercase. Majority of methods and functions are well documented with Python or the Python library. Majority of the time, unless you use it really often, programmers don't necessarily just memorize all of the different functions that is available for your like specified data type. It's very common to just look up the documentation for whatever methods are available. So if you're like, I'm working with strings, it's a good idea to look up for the Python string documentation to see what methods are available. And this gives you a sense on like how can you manipulate your data type. Majority of the times when you're programming, you often have like a documentation window open while you're programming. I think a lot of people think that you program just by like those hacking videos on TV where you're just like typing continuously on a computer, but often programmers actually have some form of reference. It's kind of like if you're an artist and you're drawing with a reference. because majority of the time you are not actually remembering everything. Here's a different example of a method. So in our previous method for upper, it does not have any needed input. So that's why you just have the parentheses and there's nothing contained within the parentheses. And that's just because of what this specific function expects. For example, for a different function like count, it needs you to give what kind of substring that you're accounting for. So this can be a single character or it can be a line of characters. For example, we're counting the number of instances of LL in the word hello, and so we only have one instance of this. And so this goes back to why it's important to look at the documentation for whatever methods that you are using, because they all have different criteria. So for count, you need to give it a substring, and you can optionally give it a start and end index for how long in the string that you want to specifically look at. It's optional, so if you don't give it, it will just look at the whole string. Information on how to use these different methods and what methods are available are all in the individual documentation. So when you're working through something, it's kind of important to look at the documentation of your data type. And so we're going back to how to write a function. We're using the function that I showed earlier in the notebook. And so this is actually the function written out in a code cell so we can run it. And so notice that once this code cell finishes running, it doesn't actually output anything. Even if we wrote a print statement, it wouldn't output anything, because this is just defining the function. We haven't actually called the function, so we haven't actually given it input, and it's not going to give us output. It's important to, when you're using functions, to define the function beforehand, or else we won't be able to call it. So calling a function is simply just using the name that you gave it and giving it input. And so, for example, we are calling the +2 function, we're giving it the integer 5, we're adding +2, and so this return key returns the evaluated x outside of the function to this return value. So these values are synonymous. The return x is almost like passing the ball to return value, and so x is equal to 7 when we print it out. So when you're thinking about functions, it is important to talk about scope. This is kind of similar to what we talked about when we're talking about for loops, that you can, if you instantiate your variable inside the for loop, you actually overwrite it. And so here I'm printing, we're instantiating x, and I'm printing the x from +2, that is returned from +2, and just printing x. And so the return value of x is 9 and 7. So how can this be? Because we only have one variable of x. So what we need to think about is scope. And so what scope is known as is what variables have a known value at a specific realm of your code. So for example, the scope of +2, we're feeding it x, and so what it does is that it creates its own instantiation of x that is separate to the instantiation of x in the wider scope of the code. So basically think of it as we're giving the function x, it is essentially creating a copy of x, performing its operation, and then returning that x. And so then it's giving us 9 because it went through this operation. But when we're calling just print x, it is calling this x, which is in the larger scope of the overall code. So these are technically both x, but one went through an operation, and that's why it is 9 instead of 7. This shows us two things. It shows us how functions actually make copies of variables and then performs operations on those copies. But it also shows us the importance of naming variables distinctly to show that these are different instances of x. And so by naming everything x, we kind of lead to this confusion, and that's why it's important to name things clearly. So from everything we've covered, you should have like a good kind of basic understanding on how to use Python. So try your hand at Sean Rhodes' Python exercises that I've linked here. He separates things from like strings, variables, and functions, and so it contains all the information that we've thus covered, and you should be able to fill it out. If you get stuck at any point, he also links to the solved exercises, but I advise that you try your hand out at first and maybe be okay with struggling a bit and look at the documentation for the methods that you're trying to use. So thank you, and we'll see you at the next notebook.